Hi and welcome back to another Mr. Talk Maths video. This week's problem is finding the shaded area of these regular squares and equilateral triangles inside this semicircle. Now, as you can see, the end triangles, equilateral triangles on top of the squares do touch the circumference of the circle, and we want the shaded area in terms of d, which is the diameter of the semicircle. If you want to have a go at this problem now, then please pause the video. Otherwise, I'm going to go through my solution in 3, 2, 1. So the first thing you want to do with semicircles or anything related to circles is try and introduce some radii on there, because then you're going to be able to get solutions usually, because specifically with this case we can get lengths of the square hopefully in terms of the diameter or the radius. So that's the first thing I want to do. I'm going to introduce those lines. So I've put a radius on there, specifically to the point where the triangle touches the circumference of the circle, because that's probably important, but also it allows me to get the radius in terms of the heights of the square, and then the width of the triangle, because that's going to be related. I say the width of the triangle, I suppose I mean the height of the triangle. So let's start putting some points onto this triangle. Now, what I can do first of all, call the width of the square x, and then this must be a half x from the left-hand bottom of the blue square to where my vertical line drops. Now the height of the orange square, as with all the squares, must be x, but then I need to work out the height of the triangle. Now to do that, what I'm going to do is do a sketch of that triangle to help me, and then I'm going to use Pythagoras again. So I've got a right angled triangle here. Now, because obviously that triangle lines up perfectly with the width of the square, then the length of the sides of that triangle must be x, and this bottom section must be a half x from the corner to where I've dropped that perpendicular line. Now I'm going to use Pythagoras to work out the height of the triangle, and so the height of the triangle must be the square root of x squared, the hypotenuse, minus a half x squared. Now that is going to give me, when we simplify it, x squared minus a quarter x squared, which is the square root of 3/4 x squared, and we get a final answer of root 3 square root of 4, which is 2, square root of the x squared, which is x. So root 3 over 2x. Let's tidy that all up and put that on the diagram.
A few minutes later.
So now what we can do is we can next put on the length of the radius. Now that's going to be a half of d, because the radius is half the diameter, and now we can use Pythagoras again because we've got it on the right angle triangle, and that will give us basically the width of the square and the length of the triangle in terms of d. So using Pythagoras, we get a half d squared is equal to, now the base of that right angle triangle is going to be 3 over 2 x all squared. And we've then got, which is slightly more complicated, the height. So that's going to be 1x plus root 3 over 2x, which gives us root 3 plus 2 over 2x all squared. That will give us a quarter d squared, and 3 over 2x squared gives us 9 over 4, square the 3, square the 2, and square the x squared. Now the next part, again, is slightly more complicated, but what we need to do is we need to treat the numerator here as if it's in like double brackets when we're squaring it. So essentially we have to multiply every term by every other term. So I'm going to do root 3 times root 3, root 3 times 2. And then I'm going to do 2 times root 3 and 2 times 2. So root 3 times root 3 is 3. 2 times root 3 is 2 root 3. 2 times root 3 is 2 root 3. So we're going to end up with 4 root 3. And 2 times 2 is 4 over, squared denominator is 4, and x squared. So we're going to simplify all of that by timesing everything by 4. So we get d squared is equal to 9x squared plus, and simplifying this at the same time, is 7 plus 4 root 3 times by x squared. We have to put it in brackets because x squared is multiplied by everything, not just the last term in the numerator. Okay, now what we can do is simplify it slightly further. So we've got 9x squared, and from this bracket we've got 7x squared. So that gives us 16x squared plus 4 root 3 x squared. And we are going to factorise it to make it just a little bit neater. So we've got 16 plus 4 root 3, and then in brackets x squared. Right, now what I'm going to do is tidy this all up, and then we're going to start looking at the shaded area in more detail, getting that in terms of x's and x squareds, and then replacing that with d squared if we can. Okay, so the shaded area we are going to start looking at. I'm going to get that in terms of x and x squareds first of all. So looking at the right hand side of the semicircle, this green shape specifically, we know that the width of the square is x, the height is x, and so we're going to have 4 squares where the area is x squared. So we've got 4x squared. And then for the triangle, you can do it in a couple of ways. But the way that we are going to do it is just the standard way, half the base times the height. So we've got 4 triangles with an area of half for the base, which is x, times by the height, which we know is root 3 over 2x. Now, simplifying that, we get an answer of 4x squared plus half of 4 is 2, and then half that again we get 1. So that will cancel that out. We get root 3 x times x, which is x squared. Factorising that, because factorising makes everything easier, we get 4 plus root 3 x squared. Now, this looks very similar to the thing that we worked out earlier, where d squared is 16 plus 4 root 3 x squared. And in fact, you might have already noticed it's a quarter of it. And so what if we do, well, if we write this as a quarter of 16 plus 4 root 3 x squared. Now, what we can then do is replace the 16 plus 4 root 3 x squared with d squared, and we get the answer in terms of d as being a quarter d squared. Isn't that neat? I think that's such a nice answer for something which looks like such a complicated and complex problem. Let's put a box around it to make it clear. Okay, I hope you enjoyed that problem, and if you were able to solve it yourself, please let me know, and if you found a different solution particularly, make sure to put it down in the comments so I can see it and other people can see your solutions. If you enjoyed the video, please make sure to like it because I really appreciate that, and if you want to, of course, subscribe to the channel. Like I say, I hope you enjoyed it, and I will see you next week for another problem. Okay, bye-bye.